Hello friends, welcome to our channel. In this lecture, I would like to explain another example based on the fixed beam. Already I explained recently another example, that is example 3 in the fixed beam. So this is a little bit different. See here what is the given data. A beam of span 10 meters is fixed at each end, carries a downward point load of 70 kilonewton at a distance of 3 meters from the left end and the upward point load of 30 kilonewton at the midspan. See here, first they given fixed at each end, means a fixed beam. So the data consists of the fixed beam. So this is the fixed beam. So in the total length of how much the span will be given 10 meters. So I am taking from this is the left hand and this is the right hand. So here I am indicating A and another end will be B. See here a span is 10 meter fixed at each end, carries a downward point load of 70 kilonewton at a distance of, so 70 kilonewton load will be acting, and that is at a distance of 3 meters from the left support. So this is the left support, and from the left end an upward point load of 30 kilonewton at midspan. See here another load will be acting like this, upward point load 30 kilonewton. So it will be acting exactly from here to here, it is the midspan. So means here to center, here also from right and left support it will be acting exactly at the centers. Means one load will be acting upward, another load will be acting downward. So what happens in the previous example, two loads will be acting eccentrically, not exactly one will be at the center, another will be eccentric. But here in this problem, so here we have to remember one thing, the load one will be acting upward, another will be acting downward. So here what are the conditions will be changes in the formula. And again at the same time in the last problem, two loads acting, one will be eccentric, both will be eccentric from end A. But here one will be acting exactly at the midspan, another will be acting eccentrically. So first of all you have to find out the fixed end moments. Clear? If you want to find out the fixed end moments, what is the formula? So already we solved so many examples, already derivations also based on this type of models. So whenever a load is acting eccentrically, A by B distance, and again here another load will be acting exactly at the center, which is L by 2, L by 2. Whenever a load is acting exactly at the center, what are the fixed moments here? What are the fixed moments? So already we solved these derivations also. Here you will get minus WAB square by L square. Because of anticlockwise you will get negative. Here minus WL by 8. Here plus WL by 8. Here plus WA square B by L square. See here, if the load will be acting downwards and it is anti-clockwise, you will get minus WL by 8. But in our case, what happens? An upward load is acting. So whenever an upward load is acting, what happens? Due to this upward load, you will get here plus WL by 8. Here minus WL by 8. So the condition suited this one and this one. So just you have to add these two. So moment AB will be equal to minus WAB square by L square, and again due to another formula you will get plus WL by 8. Similarly for MBA what happens? Plus WA square B by L square and again minus WL by 8. So substitute the values. What is W given here? 70. What is A? Distance will be 3 meters and remaining distance will be this one. This is 5 plus 2, 7. Divided by L square will be from 10 square. Similarly plus load will be 30. Total length will be 10 divided by 8. So if you simplify this one, how much you will get? So because of this value you will get here minus 102.9. So you please simplify by using your calculators, directly you will get the value. Okay, then the value will be around minus 65.40 kilonewton meter. Similarly, you have to simplify by using the same data. W will be 70, A will be 3 square, B will be here remaining distance 7, divided by L square will be 10 square, minus again 30, total L value 10 by 8. So what is the formula? Here we have to remember. So if you simplify, you will get this value will be 44.1. This one will be minus 37.5. So approximately the difference will be 6.6 kilonewton meter. So these are the fixed moments acting on the beam. So for that one, I am taking directly. I am drawing fixed BMD based on these values. I am drawing fixed BMD. One will be acting 65, another will be 6. So here I am at A point. Whenever a load is acting like this, so you will get 65.4 up to here. I am taking somewhere at the coordinate. And again, whenever a load is acting like this, you will get some 6 value like this. So add these two values. Clear? So I already explained so many times how to draw the bending moment diagram based on the obtained values. If you have any doubt regarding this, so I already uploaded so many fixed beam, so many bending moment diagrams, shear force diagrams, along with the fixed beam derivations in our channel. You please go and check how to draw the bending moment diagram based on the given moments. Okay. Then our next step is to find the reactions at the supports and draw its BMD and SFD. So already fixed BMD obtained. If you want free bending moment diagram, what we have to do? So find out the reactions from either ends. For that one, what we have to do? So here I am assuming the entire fixed beam as a simply supported beam like this. So we know the condition. Whenever we can assuming like a simply supported beam, your moments at the ends A and B will be equal to 0. So your moments at A and B will be equal to 0. So after that you have to find out the reactions at the supports. So one will be acting by 3 meters, this one will be 2 meters, so the remaining part will be 5 meters. So total length of this span will be 10 meters. So take down the reaction at A and reaction at B. So sigma MA will be equal to 0. So sigma MA will, so I am resolving here total moments about the span will be equal to 0. Otherwise you can do like this also, sigma MB will be equal to 0. So I am taking clockwise movements one side and again anti-clockwise movements another side. So what are the clockwise movements acting on the span? This one 70 into 3 and again this one 30 into 2, 30 into 5. Anti-clockwise movements, this one RB into 10. So totally 210 plus 150 equal to RB by 10. How much it will be? Sorry, here this is the upper load is acting here. I'm taking like downward load is acting. So you please take down, this is the upward load. So if you take down upward load, what happens? This will comes on anti-clockwise movement. Just small correction here. Okay. So this one will be RB into 10. What happens? Anti-clockwise towards A. This one also anti-clockwise towards A, not clockwise. Okay. That is minus 30 into 5, which is minus 150. So you will get the difference of 60 divided by 10. That one will go to RB. So you will get 6 kilonewton. So your RB will be 6 kilonewton. So if you want total vertical loads means sigma V will be equal to 0. That is RA plus RB will be equal to, again the upward load is acting here plus 30. Downward load is acting here equal to 70. Sum of the vertical loads on the span. So RA plus RB equal to 70 minus 30 will be equal to 40. Again RA will be equal to 40 minus 6 will be equal to 34 kilonewton is acting at the support. So after obtaining these points, already I told you moment A and B will be equal to 0. So here you can calculate free bending moment diagram. Free bending moment at A, for example, at A I am taking, and again at D, at B. So both are 0 because of the simply supported A. We know the simply supported end movements are 0. If you want movement at this span at C and D, so bending moment at C will be equal to this. This is acting clockwise towards A. RA into 3. So that one will be equal to 34 into 3. You will get 102 kilonewton meter. Similarly, RB into 5. Bending moment at D. So which is acting here. RB in 6 into 5, which is 30 kilonewton meter. So these are the free bending moment values. So once it will be obtained, what happens? We have to draw like this. So this 102 value will be higher at C. So I am taking this is a C point and this is the D point. 102 value will be higher. And again this what is the value? This 30 value will be lower than this value somewhere here. Okay, exactly at point C. And moment at A and D will be 0. B will be 0. So join these two lines. So this is 30 kilonewton meter and this one will be 102 kilonewton per meter. So this is the free BMD. So whatever the line we draw, it will be free BMD. So once both will be combined, it will be the resultant bending moment diagram or final bending moment diagram. So this is the way how you have to draw the bending moment diagrams. If you want net calculations, for example, if you want net moment, how to find net moment? Already I told you. So you have to find ordinate up to here and here in this line. So for this one also we solved so many examples how to interpolate. So by dividing this one like a rectangular triangle. First we know up to here in the entire total rectangular span it will be 6. So the remaining part will be based on the two symmetric triangles. So for this span, so the remaining span distance will be around some 7 meters I think here. So for the span length of total how much you will get, and for the small length of the 7 meters how much you will get, like that in the yesterday example, like in the previous example 3 also I found this net bending moment value based on this two similar triangles calculations. You please go and check once again how to draw the net bending moment values if you want, otherwise you can continue, no need. Okay, so then our next step is to draw the BMD. So BMD will be completed and SFD. If you want SFD, you can take down the calculations along with the end moments. See here, already I'm taking this entire value. I'm drawing the diagram here once again. So here the moment will be acting 65.40. Here the moment will be 6 kilonewtons. And one load will be acting which is exactly downwards. Another load will be acting which is at 30. So this is acting at a distance of 3 meters. This one will be 2 meters on the left hand. And the overall span length will be 10 meters. So here I am finding the reaction at A point, reaction at B point. So for finding the reactions, again we have to take from any either side. So now here I am finding, so I am resolving towards A or B. So either ways already I shown previously. So here I am taking resolving total moments about B will be equal to 0. So if I am taking total moments about B will be equal to 0, taking clockwise moments one side and anti-clockwise moments another side. So what are the clockwise moments acting towards A? This RA into this distance, RA into 10 meters. Again, what are the clockwise moment acting? This 30. 30 into remaining distance will be 5 plus 30 into 5. And what are the clockwise movements acting here? Plus 6. And again anti-clockwise movements comes under 65.40. And again this one 70 into 7. So if you simplify this one, how much you will get? So you find out directly RA, sending this value outside, calculate with the calculators, directly will get 39.88 kilonewton. And again, if you take some of the vertical loads, sigma V will be equal to 0. So what are the loads acting towards upwards? RA plus RB, and again another load acting plus 30. Downward load is acting 70. So what is the value? RB will be equal to 70 minus 30, and again sending this RA that side, minus 39.88. So totally you will get 40 and near to the 40, which is smaller value, that is 0.12 kilonewton is obtained. Okay, so this is the value of RB. So you know what are the values of RA and RB. Then based on this, we have to draw the shear force diagram. So I am taking the reference of this A, B, C, D. Clear? Okay, and again I am taking the reference line. This is A, B, C, D. A, B, C, D. See here, what is your RA? RA will be 39.88, which is acting upwards. So here upwards. So I am taking from here to some 39 upwards like this. Okay, again from here to here there is no load is acting. Therefore I am taking a straight line. And again from here there is a drop, which is downward load is acting. That is 70 kilonewtons. So 70 load will be coming towards, means 70 unit. So already we know this total will be 70, whatever we have to draw here. So downward load is acting, but the remaining upper part will be how much? That is 39.88, means this value, same value, which is RA value. And what is the bottom value? 70 minus this 39.88. How much it will be? It will be around 30.12. So up to here it will be 39.12. And the remaining next step is, so here also there will be no load is acting from here to here. Therefore I am drawing a straight line. If there is no load, you have to draw the straight line. Again an upper load is acting from here, okay, which is 30. So from here I am moving 30 upwards. So this is total length will be 30.12. So 30 means somewhere you will get like this. So the remaining length here will be, that is 0.12. Okay, and again from here there is no load is acting. So therefore I am taking a straight line. Okay, so you have to draw the straight line here. So again from here RB will be, your RB will be 0.12. Again from here an upper load is acting, that is 0.12. So it will close exactly here. So if you draw along with the calculations, you will get exact values wherever RB, wherever RC, it will be suited finally, which is close exactly at the 0th point, that is 0.12. So like that you have to draw the shear force diagrams along with the calculations.